Let's tackle a huge question, one of the biggest mysteries out there. Why does time only move forward?
I mean, we all feel it constantly ticking forward. But why not backward? Or sideways for that matter?
Well, the secret isn't actually in time itself. It's in a core rule of the universe called entropy.
So what is entropy really? Okay, let's break this thing down.
People often call it disorder, but think of it as just the number of ways something can be arranged.
Super simple. The more ways you can shuffle things around, the higher the entropy.
Okay, check this out. An organized army, low entropy. They can get stuff done. A scattered crowd, high entropy.
So where'd this whole idea come from? Well, it actually started with steam engines. Go figure.
Back in the Industrial Revolution, this guy, Sadi Carnot, was obsessed with why engines were so darn inefficient. So he imagined a perfect engine, just on paper, that would waste zero energy. None at all.
But yeah, in the real world, that's impossible. Energy always leaks out as waste heat.
Then Rudolf Clausius had a breakthrough. He gave this lost energy a name: entropy.
And he realized, whoa, this isn't just about engines. This is a rule for the entire universe.
It explains why stuff just happens, spontaneously. You know, like an ice cube melting on the counter.
An ice cube melts because there are way more ways for water molecules to be messy than to be a neat crystal.
You know, life itself is a rebellion against this. We create order, but it costs the universe even more disorder.
Even aging is just entropy winning out as our bodies get more disordered. And in the end, it always wins.
Okay, so let's connect it all back. This constant march toward disorder, that is the arrow of time.
Think about it. The universe started in a super-ordered, incredibly low entropy state at the Big Bang.
So that's the key. Time is just us experiencing that journey from the ordered past to the messy future.
And that's why we remember the past, right? It was more ordered, but we can't remember the chaotic future.
But where does this one-way road end? It leads to a pretty wild idea, the heat death of the universe.
This is a state of maximum entropy. A perfectly boring, uniform soup where, well, nothing happens. Ever.
So here's the final mind-bender. If change itself stops, does time just disappear? Something to think about.